created by MindSticks Foundation Trust. Welcome, learners, to today's Explainer. Today, we're going to completely demystify probability. We will be covering four main topics: the idea of probability, the mathematical formula, a little bit of practice with flipping, rolling, and drawing, and finally, the golden rules of probability. Let's begin.
Section 1. The idea of probability. Intuition first. All right, I want you to imagine a very simple experiment with me. Suppose you have a bag, and inside this bag there are exactly 4 balls, all the exact same size. 3 of them are white and 1 is black. Now, if you are blindfolded and asked to pick just 1 ball at random, what do you think will happen? Your intuition immediately tells you that the possibility of getting a white ball is much higher, right? Simply because there are more white balls in the bag. That natural gut feeling, that intuition you just had, is the very foundation of what we are studying today. So what actually happens when we take that everyday intuition and give it a formal mathematical structure? Well, we get probability. In mathematical language, when the possibility of an expected event is expressed in a number, it is called probability. We are basically taking that gut feeling and putting a precise, measurable number on exactly how likely something is to happen.
Moving on to Section 2, the mathematical formula, the language of math.
Now, please pay close attention here because these 2 terms are absolutely foundational. You need them to understand everything else we will do today. First up, we have the sample space. We denote this with a capital letter S. This is simply the set of all possible outcomes in our experiment. It's the entire universe of what could possibly happen. Second, we have the event, usually denoted by a capital letter like A. The event is the specific outcome we are expecting or the one we actually want to measure.
And here is how those 2 simple concepts come beautifully together. The probability of event A, which we write as P of A, is equal to the number of sample points in event A divided by the number of sample points in sample space, S. Simply put, N of A divided by N of S. This little fraction right here is your master key. It will help you solve absolutely any probability problem we look at today.
To make this perfectly clear, we can break down any problem into 3 simple, unbreakable steps. Step 1. Find your sample space S and count up the total possible outcomes. Step 2. Find your event A and count those specific outcomes you are looking for. And Step 3. Divide the number of A by the number of S. If you follow this disciplined, step-by-step approach, I promise you, you will never get lost in a calculation.
Let's see this in action. Section 3, flipping, rolling, and drawing, putting it to practice. Let's start with the most basic experiment you can possibly think of, tossing a single coin. Following our 3 steps, what is our sample space? Well, it can only be heads or tails, so N of S is 2. Now, if event A is getting a head, that is just one specific outcome, right? So N of A is 1. Therefore, the probability of getting a head is 1 divided by 2, or 1/2. Similarly, the probability of event B getting a tail is also exactly 1/2. Very straightforward, isn't it? Now let's bump it up and handle a slightly larger sample space. Suppose we roll a single die. Our sample space S is the numbers 1, 2, 3, 4, 5, and 6, so N of S equals 6. Now let's say we want to find the probability of getting a prime number on the upper face. We will call this event A. The prime numbers in our sample space are 2, 3, and 5. That gives us exactly 3 outcomes, meaning N of A is 3. Applying our trusty formula, 3 divided by 6 simplifies beautifully to 1/2. So exactly half the numbers on a standard die are prime numbers. Let's see how this logic holds up when we look at a much larger sample space, like a standard, well-shuffled pack of 52 playing cards. Our total sample space, N of S, is now 52. If we want the probability of drawing a red card, we have to remember there are 13 hearts and 13 diamonds, giving us a total of 26 red cards. That is our N of A. So 26 divided by 52 again simplifies to a probability of 1/2. But what if event B is drawing a face card? Well, there are exactly 12 face cards in a standard deck, so N of B is 12. The probability becomes 12/52, which simplifies down to 3/13. You see? The exact same formula works perfectly every single time, no matter how large your sample space gets.
Finally, Section 4, Golden Rules of Probability, the boundaries.
These are the unbreakable mathematical laws you absolutely must remember. Probability is typically expressed as a fraction, just like we have been calculating, or as a percentage. But the most crucial point here is the boundary. The absolute minimum value of a probability is 0. That means an event is entirely impossible. On the flip side, the maximum value is 1 or 100%, meaning an event is absolutely certain to happen. So if you are ever doing a test and you calculate a probability of 1.5 or 150%, you immediately know you have made a mistake in your steps. It simply cannot happen.
Just to really cement this crucial rule in your mind, the probability of any event is always going to sit comfortably between 0 and 1, or 0% and 100%. For instance, a probability of 1 over 4 is exactly the same as saying 25%. Please, keep this safely stored in your memory.
Let's do a quick check of our understanding. Imagine a game of chance where a spinning arrow comes to rest at one of the numbers from 1 through 8. Because the slices on the board are completely equal in size, all these outcomes are equally likely. Your sample space is 8. If you want to know the probability that it will land on an odd number, like 1, 3, 5, or 7, well, that is 4 specific outcomes. The probability is 4 over 8, which, as we know, simplifies to 1/2.
All right, now for our final and perhaps most intriguing challenge. Let's apply everything we have learned to a real-world geometry problem. Imagine a towel accidentally falls from a terrace down into a large rectangular garden below, and right inside that garden there is a circular lake. What do you think is the probability that the towel lands directly in the water?
This is where it gets really interesting. Here, the sample space is no longer just counting discrete objects like cards or coins. It is the entire physical area of the rectangular garden, which measures 77 meters by 50 meters. The specific event outcome we're looking for is the area of the circular lake, which has a diameter of 14 meters. To solve this, you would simply divide the area of the lake by the total area of the garden. It is the exact same logic, just applied to physical areas. I strongly encourage you to test out your new probability skills, find those two areas, and calculate the final answer for yourself. So what do you think the final percentage will be? Think about it. Thank you so much for joining me for today's explainer, and keep practicing.